So now, I will discuss the steps in proving the following identities. Problem A. Cosecant squared x minus cosine squared x times cosecant squared x equals to 1. In here, we use reciprocal identities to prove the expression. We use cosecant x equals to 1 over sine x to transform the expression. Since this is squared, we then squared the sine x. We then now multiply their bases and will result to 1 over sine squared x minus cosine squared x over sine squared x. Since they both have same denominator, we copy it and subtract the numerator, and will result to 1 over cosine squared x over sine squared x. There is a present identity to be used in numerator 1 minus cosine squared x, which is the Pythagorean identity. To simplify the expression, this will be equal to sine squared x. Then sine squared x over sine squared x will be equals to 1. Then the identity is verified. Problem B. In proving identities, 1 minus 2 sine squared must be equal to 2 cosine squared x minus 1. To prove this expression, we use Pythagorean identity. Sine squared x equals to 1 minus cosine squared x to expand the expression. This will result to 1 minus 2 quantity 1 minus cosine squared x. In this, we distribute negative 2 to make 1 minus 2 plus 2 cosine squared x. We calculate now the difference of 1 minus 2, which is equals to negative 1, plus 2 cosine squared x, or simply 2 cosine squared x minus 1. And the identity is now proven. Problem C. Sin x plus tan x over 1 plus cosine x must be equal to tan x. To prove, we use ratio identity, and tan x will be changed to sin x over cosine x. To simplify the complex fraction in numerator, we must find its LCD, and will result to cosine x times sin x plus sin x over cosine x divided by 1 plus cosine x. Then, we now multiply this with its reciprocal of the denominator, and will be equal to cosine x times sin x plus sin x over cosine x quantity 1 plus cosine x. Then, in the expression, we factor out sin x. Sin x quantity cosine x plus 1 over cosine x plus 1. Then, we can cancel out the common factor cosine x plus 1. Then, we come up to sin x over cosine x. Using the ratio identity, sin x over cosine x is equals to tan x. Since the expression is equal to the initial right-hand side, the identity is verified. Problem D. 1 plus cosine x over 1 minus cosine x must be equal to cosecant x plus cotangent x quantity squared. First, we're gonna take the conjugate of the denominator, so we gonna get the 1 plus cosine x over 1 plus cosine x, and multiply equals to 1 plus cosine x times 1 plus cosine x over 1 minus cosine x times 1 plus cosine x, and will be equals to 1 plus cosine squared over the difference of two squares in the denominator, which will result to 1 minus cosine squared x. Then, using the Pythagorean identity, we can convert the denominator to sine squared x, and will be equal to 1 plus cosine x quantity squared over sine squared x. Then, we can break this expression and will result to quantity of 1 sine x plus cosine x over sine x squared. And right here is equals to cosecant x, and right here is equals to cotangent x. So we end up with quantity cosecant x plus cotangent x squared. Problem E. Sine x over 1 plus cosine x must be equal to 1 minus cosine x over sine x. In this expression, we cannot easily use the trigonometric identities since it will make the expression complicated. The first step we do is to find the conjugate of the expression, same to problem D. Its conjugate is 1 minus cosine x. Then proceed to multiply the bases. After multiplying, it will result to quantity of sine x times quantity of 1 minus cosine x over quantity of 1 plus cosine x multiplied by 1 minus cosine x. In the denominator, to simplify the product, we use the difference of two squares. A minus b, quantity a plus b, equals to a squared minus b squared. 1 minus cosine squared x is sine squared x according to Pythagorean theorem. So we can cancel out the common factor sine x, and the final answer would be 1 minus cosine x over sine x. Then the identity is now verified.